Okay, 8.1 average value of a function on an interval. Okay, before we do average value of a function, we're going to review some of the other similar things we've learned. The first one was the intermediate value theorem. That's the one where it started with if f was continuous on some closed interval, and f of a was less than k, which was less than f of b, then f of c equals k for some c that is between a and b. That was saying if the y values went from 3 to 5, at some point in the middle, it must have hit the 4 because the function was continuous. Okay, and then we did average rate of change over and over again. Average rate of change, remember, was doing f of b minus f of a over b minus a. Okay, and then later we learned the mean value theorem. The mean values theorem was saying that the instantaneous rate of change was equal to the average rate of change for some c value between a and b. So that meant f prime of c was equal to the average rate of change for some c within a and b. Okay, now we're going to look at the average value of a function. Okay, I'm going to write what it is and then I'll show you what it actually means. Okay, so first requirement is that f of x is continuous. On the closed interval a to b. Okay, then the average value is 1 over b minus a, the integral from a to b of f of x dx. Okay, this is finding the average value of the function on the interval a to b. It is not finding the average rate of change, average value. Okay, let's try one with numbers and then we'll think about what the graph actually is saying. Okay, so for example, one, it says find the average value of f of x equals 6 minus x squared on the closed interval -1 to 3. Okay, let's try this formula we have here. Okay, so 1 over b minus a. So 3 minus -1, which is 3 plus 1. I'm going to do the integral from -1 to 3 of f of x dx. Okay, now before we actually solve it, let's look at the picture real quick. I'm going to do a quick little sketch. Don't copy the picture. Okay, this is my little parabola. Y-intercept is 6, and it's going from -1 to 3. Maybe like this. This is my random picture. Okay, we're trying to find the average value of the function on -1 to 3, meaning this is the value of the function. This is the value of the function. This is the value of the function. This is the value. This is the value. This is the value. These are all the values of the function. We're trying to figure out what the average value of the function is from -1 to 3. So my result should be reasonable considering the graph, and I'm going from -1 to 3. So I can see that this is going up to 6. So my answer is going to be lower than 6, but something kind of reasonable. Okay, let's keep doing the formula and then see if that seems reasonable given this scenario. Okay, let's do this. This is 1/4. Okay, antiderivative 6x minus x cubed over 3 from -1 to 3. Don't forget your 1/4. So I'm going to have 1/4. If I plug in 3, I have 6 times 3 is 18 minus 3 to the third is 27 divided by 3, 9. I'm going to plug in -1. 6 times -1 is -6 minus -1 to the third is -1. So let's make this +1 divided by 3. Okay, so I have 1/4. What is that? 15 minus 1/3 45 thirds minus 1/3. Let's go with 44 thirds. If I cross cancel out the 4, 1, 11, I get 11 over 3. So the average value of the function on that interval is 11 over 3. What is that, 3 1/3? No, it's 3 2/3, what seems reasonable, because remember that parabola went up to the 6, and then it had values lower than that. So they're saying the average value of the function is going to be 3 2/3, or 11 thirds. Okay, the next question is, when does the function assume this value? Well, the function is 6 minus x squared. So let's see when that is equal to 11 over 3. Okay, I'm going to move the x squared to this side. 6 minus 11 thirds, 18 thirds minus 11 thirds is 7 thirds. So I'm going to square root it. I get x equals plus or minus the square root of 7 over 3. However, it has to occur between -1 and 3. So it must only be at positive root 7 over 3. Negative root 7 over 3 would be lower than -1. Okay, now we're going to look at these examples. We're going to use a calculator to evaluate. The bigger question is going to be, are we finding the average value of the function, or are we finding the average rate of change of the function to make sure we're using the right formula? Okay, so example 2, set up the equation for each question, use a calculator to solve it. So h of t equals -16t squared plus 41t plus 10. H is the height in feet, t is the time in seconds. Okay, part 1. What is the average height during the first 3 seconds? They're asking me for the height. The height is the value of the function. So I want the average value of the function. It's not asking me for the rate of change of his height. They want the actual value of the height. So I'm going to use the average value of the function. So that's going to be 1 over b minus a. First 3 seconds, 3 minus 0. From 0 to 3 of that function. Okay, and then it says use a calculator to evaluate, so I'm going to evaluate this whole thing by putting it in a calculator. Use x, of course, though. Okay, my calculator gave me, I put approximately, but it was exactly 23.5. And this is the average height, so the units are going to be feet, because the height is listed in feet. Okay, so the average height during the first 3 seconds is 23.5 feet. Okay, now the next question is asking, what's the average velocity during the first 3 seconds? Okay, velocity is a rate of change. So now I want the average rate of change during the first 3 seconds. Let's see. I can use a calculator because this is a calculator question. So go ahead and plug in 3. I'm going to use my calculator. I got -11. I'm going to plug in 0. I'm not going to use my calculator for that one. So -21 divided by 3 is -7. Now my units are going to be height, which is feet, over the change in time, which is seconds. So this is feet per second. Okay, let's consider another one. Okay, for B, r of x equals 2 sine x minus 1, where r is the rate at which Santa's waistline is changing. Okay, so this is already representing a rate. Inches per month, and x is the time in months. What is the average rate of change that Santa's waistline changes from the 10th to the 12th month? Okay, now what do I want to find? I want the average rate of change. Now the function they gave me is already the rate, so I want the average of this function. The function is the rate, so I want the average function. So I want to use the average value of a function because I'm trying to get what the function represents. Okay, let's try it in the formula. 1 over 10 to 12, so 12 minus 10. 10 to 12 of his Santa function, rate of change function. Okay, and then this is a calculator active question, so I'm going to go ahead and put in the calculator. And I got about negative 2.6829. I'm going to keep 4 decimals there. Okay, the units should match the function's units. So the function was R. The units for R were inches per month. So this is still inches per month because those were the units of the function. Okay, now they're asking me what's the average change of the rate. So I want to see how the rate is changing. So now I want the average rate of change of the rate because the function R represents rate. This is during the first 5 months. So R of 5 minus R of 0 over 5 minus 0. And I would just put R of 5 minus R of 0 in your calculator, approximate it out, and I get negative 0.3836. I'm keeping 4 decimal places. Okay, now in terms of units, the units of R are inches per month. In the denominator, I have the time, which is month. So it's inches per month per month. You can write inches per month per month. I'm going to write inches per month squared for the purposes of laziness.